So today just I'll discuss about the error analysis. How to you collect the error or how to calculate the error analysis. Today we will discuss that point. Anyone can say what is the error? What is the error? When error will come? Anyone? Error कुछ पता है? Yes, simply you can tell me what is error. एग्जैक्ट थिंग को तुम नहीं दिए हो इसीलिए एरर आ गया, समझा कि नहीं? तो एरर का क्या डेफिनेशन होगा? Anyone can say?
Sir, difference of two approximate value.
Difference of two approximate value, एक original value and जो दिया गया value. The numerical solution of differential equations suddenly the differ from their exact solutions. That is error. Or the difference between the computed value and the true value at any stage is known as the total error. जब हम एरर के बारे में डिस्कशन करेंगे तो that is the difference between two value and what are the two values and true value and approximate value. That just we define now error. The numerical solution. The numerical solution of differential equations. Of differential equations. The numerical solution of differential equations suddenly differ from their exact solution. Suddenly differ from their exact solution. Exact solution. So that is called as the error. और क्या बोल सकते हैं ना, true value and computed value, when it is compared, then that result is called as the error. So total error. What do you mean by total error? Total error means the difference between computed values. One is computed values. Suppose that is naming as the yi, and true values. Another is true values. That is y of xi. So error, total error becomes, I have written here, total error. That is equal to y of xi minus y of I. This result is called total error. The total error at any stage is comprised with the truncation error and round of error. The total error is specially divided into two categories. A truncation error. You know that everybody can know the truncation error. One is truncation error. And another is round of error. Anyone can say what is the round of error and what is the truncation error? Truncation error and round of error. The most important aspect of the numerical methods is to minimize the errors and obtain the solutions with the least errors. It is usually not possible to follow the error development quietly closely. We can make only rough estimates. That is why our treatment of error analysis at times has to somewhat intuitive. Just we have to consider. So what is the most important aspects of the numerical methods? Now, most important aspects of the numerical method is to minimize the errors. The first most important aspects of numerical methods. Minimize the errors. Minimize the errors. This is the most important aspects. Minimize the errors. And obtain the solution with least errors. And obtain the solutions with least errors. Obtain the solutions with least errors. This is the most important aspect of the just you can simply the truncation error of Euler's method. In case of Euler's method, higher method we have not considered. Some methods we have omitted. That is called truncation error. You know the one case 1 by 1 plus x. What is this formula? 1 plus x plus of x square plus of x cube. Sorry, this is minus. This one is the minus. 1 minus x plus . This is the original part of the expansion by Taylor series method, 1 by 1 minus x. But when we consider 1 by 1 minus x up to consider the third degree, 1 plus x plus of x square plus of x cube, then remainings are higher order is neglected. Just think here, higher order is neglected. Whenever we neglected the higher order, just to think, so what is the remaining part? This value is comes to arises the error. This has term you left it. That means that is comes an error, and that error is called as the truncation error. This is the truncation error. So truncation error. Truncation error just produced here. What is the truncation error? Now, original function minus x4 plus x5 plus . This is the truncation error. And round of error, anybody can say about the round of error? This just we discuss about truncation error, then next will come to round of error. Round of error, anyone? When we think about the round of error, And the round of error cannot be controlled easily unless the computer used has the double precision of arithmetic facility. That means 94.86. Then just we can simply the arithmetic scene we have considered integer format, that is 95. This is called the round off. And what is the round off? 95 minus of 94.86. That is equal to 0.14. This is called as the round of error. This function is called the round of error. Just see, this is the round of error. See, this format is basically called as the round of error. So, truncation error in Euler's method, that is 1/2 h square yn double dash. So, you know the Euler's method. So, that is first one is truncation error. Truncation error of Euler's method. What is truncation of Euler's method? And that is 1/2 h square yn double dash. Or simply you can write that is OH square. While that of the modified Euler's method, that is not same. That is improve the another one term. Error of modified Euler's method. Euler's method. What is the modified Euler's method? And just error 1/2 1/2 h cube yn double dash triple dash. That is simply we can write OH cube. Like this is the Euler's method. Truncation error, the different two category. There is the modified Euler's method and the Euler's method. Just to simply think for the Euler's method order 2 and this is order 3. Similarly, the fourth order Runge-Kutta method I have already discussed, and that is also error is order 3. Error of RK method order 4. Method order 4. And what is the error of RK method order 4? That is OH cube. And in Milne's method, the truncation error, we have just discussed the Milne's method also. Milne's method. The error of the Milne's method, that is 14/45. Y and V H5. This is for the predictor method, predictor. And corrected 1/90 minus 1/90 yn 5 h5. That is the error for the Milne's method for corrector and predictor. So truncation error of Milne's method, simply we can say that h5, order of h5. Simply we can say that truncation error in Milnes method. Truncation error. In Milnes method. That we can say that order of HQ, H5. That is simply method. So just similarly, error analysis on Adams-Bashforth method of the fifth order we can define now. And that is also we can say that 19 TP is equal to minus of 251 TC. Just you look out this, I have written here of TP and TC. What are those? What is the relation of this function? That is predictor corrector. Here, this is the fifth order error of the Adams-Bashforth method. Predictor error is TP. Predictor error. And TC, corrector error. TP and TC both are the predictor error and corrector error, and the one relation is 19 TP, which is equal to minus 251 TC. This error is basically called as the errors of Adams-Bashforth method of fifth order. This is error of Adams-Bashforth method. Adams-Bashforth method of fourth order. So 19 TP is equal to minus 251 TC. That is called also the one error of the Adams-Bashforth method of order fifth. So one example we need to explain here. Apply the Euler's method just to one example. Apply Euler's method. To the differential equation. Differential equation. Apply the Euler's method to differential equation dy by dx, which is equal to f of xy, comma y of x0 is equal to y0. Estimate the total error. So just we apply Euler's method and to calculate the total error. Compute the error neglecting the round of error. One function has given you, that is f of xy, which is equal to f of xy, which is equal to minus of y, and just simply y of 0 is equal to 1. Compute the error neglecting the round off. Compute the error neglecting round of error. So that just apply Euler's method to different equation. dy by dx is equal to f of xy is given, yx0 is equal to y0 is given, and estimate the total error. Just function f of xy is equal to minus of y, and y0 is equal to 1, and compute this value. Okay, so just we find the solution of this problem. Here is given that, just see given क्या है, f of xy है, and that is value of minus y, and condition is given that is y0 is equal to 1. This one is the given. Then just we need to apply the Euler's solution. Euler's solution of the given differential equation. Euler's solution of the given differential equation. Given differential equation. So just we can follow the Euler's method. You can just remind what is the Euler's method. And that Euler's method yn plus 1, which is equal to yn plus h into function of x and yn. And just define here xn is equal to x0 plus nh. You define here. The yn plus 1 simply I have written fxy means that is the derivative part of the given function I mentioned here. Y dash. dy by dx is mentioned here. So just yn plus 1 is equal to yn plus h into yn dash. We can represent. Denoting the exact solution of the given equation. Denoting the exact solution of the given differential equation. At x is equal to xn, we can just choose a point. We choose a point. X is equal to xn. And just denote that is a function of y of x, that is y of xn. We need to find the exact solution at the point of x is equal to xn. We need to find exact solution of this point, so that we can expand the Taylor series expansion. We can expand, then we can need expand by Taylor series method. So how to expand this? And that is expansion become y of xn plus 1. That is equal to y of xn plus h into y dash of xn. And see here, plus error because this is 1/2 and y of double dash exile. This is error. So truncation error is Tn plus 1, that is truncation error. That is equal to y of xn plus 1 minus of yn, y of xn. And that is equal to this value 1/2 y double dash exile. Truncation error is simply the order of h square tends to 0. Means order of h square. This is a truncation error and that is also tends to 0. You have to consider. So to include the effect of round of error Rn, we can just include the Rn by round of error. This C you just include here round of error. Then we introduce the approximate value of yn bar. Round of error just we can introduce here yn plus 1 bar is equal to yn bar plus h into function of xn comma yn bar minus of Rn plus 1. That is the round of error. Just we can introduce this value. So total error can be defined here. Total error just define E its total error or En plus 1 as the total error can be defined here y of xn plus 1 minus of y bar of n plus 1. That is the total error. And this total error finally we computed here substituting this value and this value. Already given this value. So this value has already given y of xn plus h y dash of xn plus error. Second value, this is minus yn bar plus h into f xn yn minus Rn plus 1. Just we can subtract it. That is the total error we have to evaluate here. So this is the solution I can simplify, and that is the error of the total function, and that is going to be produced En plus 1, which is equal to y of xn minus y of n bar plus into, just to consider the taken common, then value becomes 1 plus f y fn of y, this function becomes xn exile n. This is the value. For xn exile n is lies. This is the exile n. Exile n. This value just error part of yxn and yn. This value is the error part of yxn and yn, and plus of Rn plus 1 plus Tn plus 1. This is called as the error analysis of this function by Euler's method. So just you can see, simply overlook this point. One problem is given you, and you have to apply the Euler's method and expanding by using the Taylor series method and evaluate the error for this function, and for using the round of error and total error, and that can be used to this minus of this and finding the error of this function. This is the value. This recurrence formula for finding the total error only. This formula we have used for finding the total error only. And simply whenever this calculation is completed, so that is we can write simply from En plus 1, which is equal to En error into 1 plus h into function of y into x and exile n. Exile n plus Tn plus 1 plus Rn plus 1. This is the error analysis for calculation of the total error. So that the recurrence, this formula used for calculation of the total error. The first terms on the right hand side, invariant error. The first term of the right hand side is called as the invariant error. Propagation error from the previous of Yn. So next we'll discuss the convergence of the method. This is specially we have to discuss the error analysis of this problem. How to use the error analysis by using the Euler's method. And that is the problem I have given you. Dy by dx is equal to minus of y, y0 is equal to 1. Then you can compute by the method how to evaluate this error. Now just come to, this is the general process for the error calculation of the Euler's method. Now to our solution part is problem dy by dx, which is equal to minus of y, and just given that is y of 0, which is equal to 1. This is our problem. And our objective is to evaluate the error of this problem. So just we take h value is equal to 0.01. And applying Euler's method. Then Euler's method, here x0 is equal to 0 and just y0 is equal to 1. Then need to apply the Euler's method. What is the Euler's method? Then y of 0.01 is equal to y0 plus h into function of x0, y0. That is 1 plus 0.01 into minus 1. One you can put here this value. Then this value becomes 1 minus 0.01. That is equal to 0.99.
Hello, sir.
Hello.
Sir, your age is given or we have to take it?